Good afternoon, everyone. Welcome to the post-lunch session. I will try to be dynamic to keep you awake. My name is Greg Ritter. I am part of the higher education strategy team at Amazon Web Services, and I'm the lead for strategy around libraries, scholarly communication, and research data management. And I'm very excited to be joined by the group here, all of whom I've worked with them or their teams on really exciting generative AI projects this year that they are going to share with you. I am going to just provide a little context up front and try to get out of their way as quickly as possible because they've got the interesting stuff to share. But I'm joined by Sarah from Weill Cornell Medicine, Cory from The Ohio State University, and I had to do that. I've wanted to do that ever since I've been an NFL fan. And Joe Naccarato from University of Delaware, and they'll each provide their own introductions when they share about their projects. My role here, as I said, is to introduce these very smart people and to provide a little bit of context about two things in particular. First is Amazon Bedrock, which is Amazon's generative AI application building platform. And then the second is about some innovation programs that AWS provides at no cost to our customer institutions and organizations. All of the panelists up here today worked with one of our innovation programs. That's why I was excited to bring them all together here because I got to see some of those innovation programs in effect. So I'm not going to spend a whole lot of time talking about Bedrock. If you're not familiar with Bedrock, it is a cloud-based managed service provided by AWS that allows you to build generative AI applications with a wide choice of generative AI models. So you have a choice of somewhere at this point, don't hold me to the number because we announced a bunch more models last week at the big International AWS conference in Las Vegas, reInvent. But we have models from AI21 Labs, from Anthropic, from Cohere, from Luma, from Meta, from Mistral, from Poolside, from Stability AI, and Amazon's own model, the Amazon Titan model, and the new next-gen models that were announced literally just last week, Amazon Nova. So the really, I think, important thing for education in particular about Amazon Bedrock is this maintains all of your data in your own AWS environment. That data is encrypted in transit and at rest, which means neither AWS nor any of the model vendors have access to your data, or contractually, we won't use that data for further training of the models. So this runs in a sandbox of your institution's control with the usual AWS enterprise-grade security privacy. We don't use the data to train models, and we support a lot of probably most of the privacy requirements, particularly around things like GDPR and HIPAA, that are important for some of the kinds of research that institutions want to be able to do. Then we have the innovation programs that I mentioned. I'm going to mention three here because each of our panelists worked with a different innovation program from AWS. This is not the limit of all of the innovation programs and acceleration programs that AWS provides to our customers, but the goal is to provide resources to help our customers innovate and tackle really interesting challenges and problems. So the Generative AI Innovation Center is a team of data scientists and software developers at AWS, and they help your organization build or even just ideate around generative AI projects. These are usually 6 to 8 week engagements that include an upfront diagnostic process to help clarify the requirements and identify the outcomes. It can stop there if you just want that from the perspective, but we also have a team that can actually build a proof of concept for you. The other one, and actually Sarah and Weill Cornell Medicine partnered with the Generative AI Innovation Center for the project she's going to talk about. Another one is Cloud Innovation Centers. This is a really kind of unique program where AWS partners with select higher education institutions to support challenges in the public sector, in government, and in education. So what we do is we embed AWS staff at the institution, and they support and mentor a team of students, graduate students, and undergraduate students who take on these challenges as, again, typically 4 to 6 week projects to create a proof of concept that will then be delivered to the institution. One of the great things about this is all of those proof of concepts are open sourced as well. So they're all shared back with the community. We have 3 KICs in the US at Arizona State University, at Cal Poly, and at UC Davis Health Sciences. There's one in Canada at the University of British Columbia, and then there are several more around the globe. They are focused, while the GenAIC focuses on anything around the world. They work with corporations and governments and education, et cetera. The Cloud Innovation Centers are focused specifically on public sector institutions. And then finally, the Customer Acceleration Team is a team of solution architects from the higher education organization. So this is an EDU-specific, I should say education organization, because they support K-12 as well. This is an EDU-specific team, and they work with our institutions on 5 separate areas: artificial intelligence, data and analytics, cybersecurity, migration and modernization of applications to the cloud, and cloud-based call centers. And they're a little bit different in that the other 2 innovation programs will actually provide code for proof of concepts. The Customer Acceleration, or CAT team, is an over-the-shoulder kind of collaboration. So they'll come in and they'll help you with scoping your project. They'll provide enablement sessions or training sessions to help get your team up to speed. They'll help you design the architecture and more. Joe worked with the CAT team, and I think I failed to mention also that Cory and his team worked with the ASU Cloud Innovation Center, which specializes in artificial intelligence. And that's all you have to hear from me. So I'm going to turn it over to Sarah now, who is going to talk about the project at Weill Cornell.
Great. Hi, everyone. Thanks, Greg. Delighted to be here. My name is Sarah Mamaar. I am the Associate Director for Research Services and Scientific Computing at Weill Cornell Medicine, New York City. And I'll be presenting a small project we've been doing with our old patient medical records from the archives and how we use generative AI with those. So before I dive into the details, I wanted to acknowledge all the people that contributed to this project. That was definitely a teamwork. Dr. Cole, who is our Vice President and Global Chief Information Officer, he's about both of the ITS and the library. He's a physician, and he was the one spearheading all this project. Vinay Varagese, our Senior Technology Officer from ITS, also contributed. Obviously, our archivist, beloved archivist Amanda Garfunkel, and Tally Hand from the library helped as well. I was a part of it. I wear 2 hats, both in ITS and library. We also got partnership from Leap of Faith company, who provided us with 5 fantastic interns from the Institute, Illinois Institute of Technology. They were supervised by Anna Cole Crosby from UC Davis, and obviously we wouldn't have been able to do that with our partner in AWS, Sandra, Tyler, Noel, Greg, and many others. So let's dive into it, and a little bit of history about our library, the Samuel J. Wood Library. So Weill Cornell Medicine, or formerly Cornell University Medical College, has had some kind of library since the 1900s. But it's really in 1932 that the college decided to invest into a medical center. And at that time, the library gained this additional room, the reading room that we use, and finally got a little bit more space to store those kind of material, the archive material. In 1950s, they realized that the foot traffic doubled, so they decided to expand the library, and this is when the Samuel J. Wood Library, along with the research building, was built in 1962. Fun fact about this is that you can see a picture of Dr. Fauci, which is one of our famous alumni. Actually, in 1960, he was a young student, 20 years old, and he was working part-time as a contractor during the summer to pay for his medical studies. And he got pulled into a construction site that was the Samuel J. Wood Library construction site. And he likes to tell to students that he was, when he was entering the library in construction, he was dreaming about entering it as a medical student and not as a contractor. And 2 years later, he got admitted and started his clinical training. In 1989, we had an additional expansion, and now the Samuel J. Weill Library is part of the CV Star Biomedical Center. That includes also new computers and other information resources facilities. And it has really changed since then. The Samuel J. Weill Library is still very much of the department's, medical department's efforts into advancing science and arts, and we're trying to stay really ahead of the curve in terms of technology. Now, about the Medical Center Archive. I mentioned to you the Medical Center was built in 1932, but it's only 40 years later that we got a dedicated space that we could call archive to store all our records from both the New York Presbyterian and the Weill Cornell Medical Center and our affiliated institutions. Just as a context, the New York Presbyterian Hospital is the third oldest hospital in the U.S. It was founded in 1771. So a lot of materials out there. It's also it's ranked as the 7th best hospital in the U.S. So it has a lot of history, and I believe a lot to bring to the table. We're currently managing 10,000 linear feet and about 11 terabytes of material, records, papers, photographs. And you have a dated picture of the archives on the left. But that's very valuable because that really allows us to trace back the history in healthcare, clinical training, scientific research as well. So we really think that's valuable, and that's how we decided to partner with the AWS to help us do something with it and make it more accessible, especially to the public and to our faculty students. It is accessible to the public, so anyone who can come to New York City and to Weill Cornell is welcome to check it out. Now, about the Leap of Faith project, this is how we baptized this project at Weill Cornell. So we have our collection in the archive contains patient medical records from 1808 to 1932. For this project, we focused on the one that were between 1850s and 1870s, which are an interesting time because this, for example, around the time when the first woman was graduating from medical school in the US. So that has some interesting value there. We have thousands of volumes which contain handwritten patient medical record from both medical and surgical division from the New York Presbyterian Hospital. Unfortunately, we only have 113 volumes that are digitized as of now. So that's very little, and it's about 65,000 TIFFs. Each TIFF looks like a 1 or 2 case, and it's pretty structured. So you would have the patient name, the diagnosis, the treatment, and the different encounters with the physician, and of course the outcome, all handwritten. So 10 years ago, we had a first attempt to transcribe those patient medical records, and we had about 80 to 90% in transcription accuracy. That was not too bad, but we definitely couldn't upscale our transcription. So this time we decided to leverage generative AI and large language model to try to correct for those mistakes and incongruencies that we could see in our transcription back then. And the other innovative part of it is the integration of the intelligent medical object pipeline, which has been developed by Leap of Faith, and that basically allows us to map medical terms with medical coding system. I just put a few here, but so that would help modern physician to look for also those records in a light of current context. So 2 steps project at the end. The first one is to transcribe and improve the accuracy of the digitized data and do the mapping. The second is also to build a database. So those records can be searched, indexed, and the notes can be labeled. So that's also has been one of the objectives. So here, please, no picture, I'm sorry, but the New York Presbyterian Hospital is very protective of their data. It's de-identified, but they wanted to still be treated as HIPAA data. So this will be stripped out of the recording. But it's just to show you that we have different fonts, and it's really not easy to read as a normal human being. One thing that is interesting about those records, it has the clinical decision describing them are very modern for 150 years old records, But the funny thing is that it has a lot of old measuring units. For example, they don't use grams, they use grain. They use drachm or ounces, and they have like very weird symbols and old letters that we don't use anymore. So not easy for a generative AI tool to transcribe. But we tried. One thing also that we did is that we recruited people in our ITS group and asked them to take one record and manually transcribe it to the best of their ability. So we could use this as a data set, as a ground truth data set. And so we had an encoding system for them to follow. So they could say, okay, for this word, I'm not so sure. They would put 2 double brackets that would allow the machine to operate on that and the model to know that this word is to be taken with a grain of salt. So the resources that we used were obviously AWS. We had an AWS account, the command line interface. We relied heavily on S3 Bedrock and TextTrack, which is an optical character recognition tool that is currently commonly used, and also the DynamoDB services. Obviously, we also leverage a generative AI model, Claude 3.5 Sonnet through Bedrock, a bunch of Python libraries, and our IMO pipeline from Leap of Faith. And we tried 2 approaches. The first one was to use just basically the images and ingest them to give them to Claude and ask Claude to transcribe the pictures. And then take the output and give that to IMO pipeline and see how it performs. The second approach was to add TextTrack just before Claude, just to see if we could improve even better the accuracy. So TextTrack is really, again, focused on optical character recognition, as opposed to Claude, which is more versatile. And same, then the output would be submitted to IMO. And so during the project, we built a database that I mentioned before. So that database is the one storing all the extracted text, but it also captures a bunch of metadata that might be of interest, especially for I would say, from a library perspective. So it captures the date and the time of the record. It captures where it is located exactly, how many cases are there in each record, and so on. And it has a graphical interface, which is pretty nice. So the first thing that we looked at, obviously, after trying those 2 approaches is the accuracy. How did we perform? And so the way we compared the accuracy was basically to take the extracted text with both approaches and compare them to our manually transcribed text that we labeled as ground truth data set. And to do that, we relied on embeddings and cosine similarity. So in case you're not very familiar with embeddings, so it is, to summarize, a numerical representation, a vector that you could place in 2D space, and that would capture the semantic meaning of your word. So the closer in the space they are, and the more the meaning is similar. And we did that using Claude Sonnet, 3.5 Sonnet. And then we used those embeddings, and we calculated cosine similarity. So if you have a score of -1, that means it's completely opposite, meaning score of 1 means identical, score of 0 means completely different meaning, or not similar. And those are the results we got. So you can see here in this table a percentage of similarity between the different approaches. Claude was the one performing the best, 97% compared to our ground truth data set. But note that TextTrack is not really far behind, 90%. It's not bad. Interestingly, when you add Claude to TextTrack, you increase actually the accuracy by 4%. So it's worth noting that Claude is actually adding value to the transcription accuracy. So what we concluded out of this work is that the direct Claude approach was pretty good with handwritten text because it takes in the image directly. TextTrack and Claude, we think they are better with typed or printed document. That's what we noticed. In terms of processing speed, TextTrack and Claude were much better for larger volume of documents. And we think because TextTrack is just optimized to extract text from documents. Now, in terms of flexibility, the interesting part is that we noticed that Claude was performing much better if you had a document that has both graphs and text, like various types of document, or information in there. While text and Claude we found more suited to something that is more a classic text. But so we found that both approaches had merits, and it really just depends on what you're trying to do and the type of document you're working with. We built a graphical interface for our tool. We used Streamlit for that. So this is how it looks like. You can just upload a file from your local computer and decide which approach you want to use. You have approach 1 or 2, Claude or TextCrack plus Claude. And it will output the transcription below. And then you can choose also to compare the two approaches side by side and check how it is performing, just extract alone or plus Claude and so on. And so overall, I think that it was a success. I mean, given that the project was just for a month with 5 interns, we're pretty happy with the results. We had issues. We don't have issues, but we're looking further into the accuracy because we use embeddings. And the thing with embeddings is that we noticed that it's more prone to accept metaphors, which we don't want in that case. We really want to be as close as possible to the original text. So we're looking into that. We are also working with AWS to increase our capacity for batch processing. So far, we've been only processing 3 by 3, like 3 TIFFs by 3 TIFFs, which is really not much when you have 65,000 to do. And then we are looking into integrating more our IMO partners pipeline. So it's more automated. What we really would like to also develop is our DynamoDB database, so make it more searchable, create an API so researchers can directly interact with the records and search it dynamically. And of course, improve error handling, and that's pretty basic at the moment. And that's it for me, and I'll pass it over to Cory.
Thanks, Sarah. Well, hi, everyone. I am Cory Tressler. I am the Assistant Dean for Technology and Digital Programs at The Ohio State University. It's really great to be here. Hopefully, y'all are having a great CNI. So I've been with the libraries for about a year. And shortly after I started, or a couple months, the federal government changed some laws around digital accessibility. Many of you in the public areas that, like Ohio State, are probably well versed on this. You've probably sat in numerous webinars, as I have. At this point, I think we're saturated on the current understanding of the law. It'll be interesting in a couple years when the first group gets sued around these rules. Then we'll decide if we were right or we were wrong. So where we're at, similar to, again, many of you, we're an R1 research library with lots of things. So hundreds of thousands of PDFs, really hundreds of thousands of images, a whole bunch of stuff. And it's not even including, like many of the conversations here, about things in our archive that we haven't even got to digitize yet. So we have a lot of work ahead of us. So when we saw these new rules and started to dissect them, it got very daunting and very concerning, let's say. So after we, proverbially freaked out for about a month or two, my team was like, well, what are we going to do? Because I manage the team that sort of makes sure all of our collections run. I manage the team that works with AWS on our storage of the back end of everything we have, and was like, okay, what can we do? Fortunately, AWS held a learning day at our campus, and I attended. And one of the sessions was about the KIC group that Greg had mentioned. And I was like, well, I have a problem for you. So after a session very similar to this, I grabbed the presenter and started talking and seeing where we could go. That led to an engagement with KIC between Ohio State and them. It was a really wonderful sprint. It was about 6 to 8 weeks long. Again, like Greg said, wonderful students, a lot of experts from AWS, really diving in to see what is on the market currently. So we're not saying, let's start from scratch and just develop on this and figure this problem out. It was more like, how can we connect the dots? What is available across the industry and what isn't potentially, so that we knew what we were getting ourselves into it, because we really needed to figure out, especially PDFs. When you have hundreds of thousands of them, many of them in which have never been thought of from a digital accessibility lens, 15 years ago or whatever, a few of our repositories, literally the instructions are save as PDF in Word and upload. No context for anything else. So a lot of issues. One repository we have has over 100,000 documents in it. Some are from undergraduate students that had to meet a graduation requirement, grad students that were doing first draft on things they were submitting, and even scholars that were preprint sort of adding in their scholarly work, so it was in our repository. So all over the map, just in one of our collections. And so we need a solution because we can't afford the human solution. We don't have time, really. Ohio State, and many of you may be in the same boat we are, we have until April of 2026 to get fully compliant to the law. With all of this, not even counting our learning management system, our ERP, our HR system, many, many things. And currently, I will just say, we got about 80,000 applications for entrance as freshmen last year. Each one of those applications creates 18 PDFs, none of which are accessible. So that's my friends in Central IT. We are having sort of conversations about how they can use some of the things that we're working on that we discovered during KIC. And what we discovered is there are a few tools out there, and you need to create sort of a workflow app, if you will, to solve some of these PDF remediation. So this chart, and it'll be available to you, and then the bottom right, all of this is open sourced and documented for you as well. It basically, takes the PDF from a S3 bucket and then passes it over to some Adobe tools. The Adobe tools are wonderful. They do about 80% of the work right out of the box. Now you have to get access to them, and there is a cost to running them, which I'll talk about in a minute. But when you're talking about the framing of a document, how are the headers presenting themselves? So what are the margins looking like? Is there metadata embedded in it? Because if you've ever sat by somebody using a screen reader, oh my, if the document is not ready for it, it is a mess. Now, a lot of people that use those screen readers are used to that. Is that a good solution? No, absolutely not. So we need to do better than that. And that's why this work is something we can all get passionate about, because this is what we need to do. It's the right thing to do, even though it's a little scary, the timeline of things. So the Adobe tools do a lot of that. It extracts the PDF that it was given, pulls it apart, fixes all the framing, pieces it back together. So great. All right, there's the first 80%. The last 20%, which is of course the hardest, is graphs, images, anything else that needs alt text or some sort of analysis to, again, speed up and automate the process. Because, when we're talking about things, say, in the health sciences or in different areas, yes, there might be a caption under that chart, graph, whatever it may be, but then interpreting that chart or graph for alt text is a whole different bag of goodies to try to figure out. And let's say many of you may use students for accessibility right now on remediating PDFs and content like that. Putting some of this context in front of an undergraduate student, you're probably not going to get the results you wanted anyways, because the context of the document is probably going to be confusing to many in this room, not just to say an undergraduate student. So that's where the generative AI models come in. After it sort of reframes the document, it then points those charts, images, graphs, whatever they are, at LLMs. And it deciphers that information and then gives us back that alt text, pass it back to the Adobe tool, stamp it, if you will, the alt text into the PDF so that the screen reader will get it, and then out, you have the PDF solution at the end of this chart. All of this can take about 20 seconds. So pretty great. Like you throw a 100-page document at it, yeah, that's awesome, in 20 seconds later. So here's where we're at though. And this is where it gets more complicated and why we need to do more testing on this. I'm not presenting to you an end solution that we have and we stood up completely. We are still in the development phase and trying to figure out exactly which LLMs are going to be the best for which types of content we're throwing at it. So you can see in our results from a financial standpoint, this is looking pretty good. Now, at Ohio State and many of your universities, I still have millions of pages I need to do. So even though we've gotten it down to 6 cents, and I should put in there, since Greg's standing right here, the AWS cost is the lowest part of this. Some of the Adobe tools does have a little bit higher costs, as I mentioned. I would encourage you to have conversations with your Adobe rep and your team that manages your Adobe license to talk about how you can potentially leverage those APIs, because they are not standard within a normal Adobe contract. Ohio State uses, obviously, Adobe for a lot of things. We have Creative Cloud, or we did have it for everybody. We still have it for all faculty and staff. But this was not included. This is more a developer toolkit type of API system. So it takes a special conversation because you may not be leveraging it at all right now, or at least not at the scale we are trying to. But when we had some documents that were $3 to $4, now that's more on the digitized content, and we're focusing on Born Digital right at the moment, but we will shift to our digitized content soon. Again, as we're developing and as we're testing things, down to 6 cents a page. That's a pretty remarkable just win right there about thinking about how I can scale this from a budgetary standpoint and have conversations with my dean and the provost and leaders across the institution. The other part of this is always time, because time is money, and we have this looming deadline in 18 months from now, ish, or 17, I guess, if I did, there's 14, sorry. So I think about this a lot, and it does keep getting shorter and shorter. Right now, a 100-page PDF takes hours, regardless of who you're giving it to, a vendor, student, worker, train them, whoever it might be. It's not going to be that day you get that output back. Literally seconds to do this with this AI solution. So that is really valuable to us. And that's why this sort of last bullet here, we are in development of multiple tools. So not just one tool of a PDF end to end. We need that, absolutely need it. But we have a digital collection in the hundreds of thousands of images. We have, I believe, the only cartoon research library in the world. We have a lot of TIFF images of those scans of those newspaper dailies or whatever that were run, the New Yorker, all those things that we have scanned in from either direct donations from the artist or other. That's a lot, So we are also developing an alt text generator that would be standalone service. And all of these things, we could have multiple versions of it. So we envision potentially for something like our knowledge bank, which is a large repository of research data, that we could potentially do, say, the top 20% of those PDFs and just have them ready for anybody. We're also thinking about an on-demand solution, and this is where the rules get a little fuzzy, because the rules read as if it all needs to be done by April 2026. Well, I don't think we're going to get there. So if I can create an on-demand sort of button that's sitting right beside that PDF, again, S3 buckets, all architecture to DSpace or wherever it is, and the end user, the patron, taps on that, and in 10, 15 seconds later, they have the remediated version. I'm hopeful that the rules will be, and the judges and the juries that will be deciding this will be okay with that, because we have shown really good faith effort. We have developed a solution, and honestly, 10 to 15 seconds is like a slow internet page load anyways. Or we talked about the 90s earlier in this kickoff, a very fast internet load speed in 1996 or 97. So I'm hopeful there of that on-demand solution in the PDF side. The alt-text side is something that's even really more compelling because we could run that across a lot of different things. So again, our digital collections have many, many thousands of images in there. So we are going to try, and this is what we're testing now, which LLM is going to work best for which things. So we have a lot of landscape images. So we have a Bird Polar Institute, which does a lot of climate and research data in that space. So a lot of trips to Antarctica in, say, the 50s or 60s, and we've digitized those slides so researchers can see those. Well, those are one thing. Well, what about comics? What about cartoons? What about those things that have text integrated into artwork? How do you interpret that and create alt text around that? Which model is going to be the best? So we are looking at a solution that, for depending on the type and the thing you're looking at, it's going to grab a different model based on accuracy and then apply it. So we're going to have to do a lot of, again, service engineering to get this stood up. Thankfully, a lot of this is serverless and we can stand it against basically anything we have. But we'd also potentially create some tools for our employees on the back end where they could run it themselves. Because an institution, again, of many of our scales, the training aspect of how to create accessible documents in the future is going to be really, really challenging. Because that is one of the solutions I'm hearing at Ohio State, where we have about 100,000 employees, is just to train all of them so that when they're using Teams, anything they put in Teams will be accessible on April 2026. I doubt that's going to happen. So again, creating tools like this where I can hand it off to the end user and say, before you share that PDF, before you share that image, here, run it against this, and 10 seconds later, you have it. Again, there's a cost of doing business, so we're going to have to budget around that and think about that very carefully. But that's what we're looking at right now. So again, two tools to run sort of different services against. And then, oh, by the way, I'll just add this because this has come up in a couple other sessions. We are looking at how can we handle some of the backlog of digitized stuff that we have. Or there was a session in this room exactly just, right before lunch, or the session before lunch, about donations. So again, that cartoon library, we get donations of born digital content that's just insane scale. And they were talking about 90,000 emails. Here you go. Here's all the emails and all my production files and everything. Well, when you have everything, that creates a lot of challenges. So we have really gigabytes of data that's sort of sitting there in files that's in our backlog that hasn't made it either into our repositories, our deep archives, or even in our forward-facing content for patrons. Could we run some things like the alt text tool against some of that data and create just enough metadata so that future us will have a better understanding of what a current us stored there? Because some of our backlogs are in the years, not in the months. So we aren't going to get to it this year. So could we create just enough metadata so that, again, down the road, we could get to that and have a little bit of a head start when more and more tools are developed and potentially have different solutions that could streamline that process too. So that's what we're up to. I appreciate your time, and I'm going to hand it off to Joe.
So hi there, I'm Joe Naccarato. I'm an educational software designer from the University of Delaware, and I'm here to tell you about our project called UD Study Aid, which aims to take professors' lecture capture material and turn it into study aids and learning objects that the students in their classes can use on a daily basis. So I'm just one of a rather large team. We pulled people from across the university. I'm a programmer, my fellow programmer, Javanya Harris. We also have instructional designers, people who work directly with faculty to help us come up with what makes good learning objects, that kind of thing. And we have grad students, undergrads who have all worked on this project. So the idea came from Javanya. She had worked on our university's in-house lecture capture system when it was first launched 20-some years ago. And when ChatGPT came on the scene, she realized we hadn't thrown out any of that lecture capture data. So it was all there to start looking through. She contacted a faculty member that she was familiar with and said, hey, can I take some of your transcripts and see what I can do with them? She ran them through ChatGPT. She asked some different questions and found out she was really able to create some interesting, good learning objects, things like flashcards, multiple choice questions, case studies from the lectures that she had. So then the challenge became, so how do we make this something that everybody could use? One of the first things we had to do was actually sell it to the faculty. And one of the big points here is that this is a tool, it is not a replacement. We're not interested in creating an AI faculty member. We're interested in giving you something that can help you speed up the creation of your course. You aren't going to have to sit there and think about different flashcards, different ways to help the student. You can have this catalog of things created for you. And that's kind of how we got faculty on board to kind of join us in this project. Then we started thinking about things like the ethics behind AI, how the models are created. That's where we pulled in some of our grad students and our undergrads to kind of start looking into the background of some of these models, where the data came from, that kind of thing, so that we could create something that was innovative but also met our kind of ethical standards. And so what we came up with was a system that looks like this. We started with our UD capture data. We asked the faculty member to let us use that. We asked them what kind of data they want, which lectures they want, that kind of thing. And it creates kind of a package of data that we can then send through an LLM through Bedrock. It comes back with all the topics, subtopics, definitions of those topics that it finds within those transcripts. And what it does is then we present those to the faculty member. So again, we're keeping the human in the loop kind of all the way through this, which is again another way of getting them on board with what we're doing, because it lets them kind of choose what's happening. Once the faculty member approves of all this information, we take it and we store it in something called a knowledge graph. If you're not familiar with that, it's a kind of database that allows you to have nodes and relationships, and you end up with something that looks kind of like a constellation of stars that are all kind of connected, as opposed to sort of the spreadsheet look of like a relational database. Once everything is in the knowledge graph, we can then pull out the data by topic and start creating learning objects based on that. So we can say, give us, the first thing we did was psychology. So give us all the information that this professor has ever said about growth mindset and give us flashcards about this. It creates those learning objects, stores them in a database, and again, presents them to the faculty member to say, this is what I've created for you. Do you like this? Do you not like this? So again, keeps them in the loop. They can look at these learning objects and figure out what works for them and what doesn't. So that's kind of the process. It all relies on Bedrock. We chose that because it allows us access to, one, it keeps the data private, and two, it allows us access to a wide variety of LLMs. So like Cory was saying, we can choose kind of what LLM works best for what learning object, what course, what subject, et cetera. We can kind of flip that out as needed. We had a prototype working on site, but if we want to make this available campus-wide, we have to be able to scale up, and that's where AWS's CAT team came in. Giovanna and I were not AWS programmers. We knew it stood for Amazon Web Services, but other than that, we hadn't really spent too much time with it. And so we sat down with their engineers and they guided us through the whole thing. So we came out being complete novices to being comfortable with the system. Again, there's still more to learn. There's always more to learn. But they helped us design a solution that could scale up much more rapidly than anything that we could do on premises on campus. We just didn't have the computing resources designated for this particular project. So that's where AWS came in. What that allows us to do again, and this is the knowledge graph. This is kind of the thing that people like about this project. This is actually the Psychology 101 course, all of the topics connected to all of the lecture materials. That data is all connected together. Once that's there, it's almost like a roadmap for other things, because that data can go not just within that course, but you could pull that data across course. You could see what professors are talking about growth mindset across the university campus. You can start to even move in stuff about the learning objects. So how many students are using this one? How many students are using that one? You can put all of this together and you really have like a roadmap that the cool thing about this is that AI is really good at following knowledge graphs. So by creating this map, we have something that then AI can travel across and find new information for us. So what does this look like? Basically, this is what you look at when you see a course. We divide it into the course, the faculty that taught it, the subject it's in, and then we point a specific material to a faculty member. We break that down. The important part about breaking it down, we do that so that we can trace back exactly where these learning objects came from. So when we create a flashcard, we know the exact section of the transcript where it was produced from. So we can actually trace it back a little bit more effectively than something like a standard RAG, retrieval augmented generation, where you kind of get the document, but maybe not the specific text that was within that document. You'd have to do a little more searching. But at this point, we could even then say to, when we display that flashcard, we can say to the student, like, hey, this is where it came from. The student can click and boom, there's the video, there's the exact part where the professor is talking about that, so they can kind of relearn what they may have missed. And connected to each chunk of information is a topic. And those topics are going to be graph-wide. So they aren't just for Psychology 101. They could connect to biology, whatever, because they talked about the same thing. So those topics can help us connect across campus. So we also have these learning objects in here. And again, those are also connected to the topics, and those are connected to those chunks of material that we created beforehand. So again, that knowledge graph is really showing kind of tight relationships between data. So we create this, again, with the faculty in the loop. So they get an interface that allows them to see exactly where they are in the course. It shows them exactly what was pulled out from the LLM and gives them the ability to change it. So nothing goes into that knowledge graph until the professor says it's okay, until they approve it. And they have the ability to kind of change anything along the way. So if they want to call the topic something different, that's fine. If they want to, change up or remove some of those definitions, that's also fine. Again, once they have everything kind of set up the way they want, they hit a button and boom, it goes into a knowledge graph. And so there's kind of like a close-up view. So you can see the topics, the course, and some of the text that's there. Once that's created, then we go into saying, okay, let's create some learning objects for you. And again, they have the ability to say yay or nay to any of these. We have not given them the ability to change the actual learning objects for initial data collection. Again, this is new, so we're trying to see really how good the LLM is at doing things. So we want to look at kind of what they accept, what they reject. But you'll notice they also have the ability, there's that reddish purpley button that says view the node context, so they can see like, hey, I didn't think I said this. Click on that button, boom, there's their information. Kind of sometimes you get funny ones. There was we try to prompt out for things like student conversations or sort of side things. The LLM is pretty good at understanding when people get off topic and start talking about personal things. But the professor was discussing something about her wedding, and one of the questions was, why did the professor talk to the students about the cost of their wedding dress? The answer was because it was expensive and she felt like she had to, or something along those lines. But you get all kinds of funny stuff like that when it kind of misses, which is, again, why we keep the human in the loop, because the last thing you want is your student running across that as a flashcard question as they're trying to study for their test. So again, and here's kind of what you see as a student. We give them the ability to create their own custom decks of cards so that if there are things that they want to study over and over again, they can kind of add them to this deck and track how they're feeling about it. So green, thumbs up, hey, I'm good here. Yellow, I still need to look at this. And red, I have no idea what they were talking about. I need more help on this one. This leads to some ideas about helping students learn to study. Because one of the things we found with this project is once that knowledge graph is there and once you start adding all this data in, there's all kinds of other use cases and things that crop up, whether it's helping students learn to study or things like, hey, what is taught across my department for accreditation purposes? So here's kind of an idea that we're working on for study sessions that would track kind of how the student goes through what learning objects they've come across and kind of what order they've done it in, so we can figure out kind of what way they study best. Again, part of this is also making sure that students have access to all this data and that we kind of want to anonymize it from faculty. Students might not use it if they feel like people are kind of looking over their shoulder. So the study session, this is for the student to learn about the student and how best they study, how best they work. We're also looking at doing things like adding more content types. Right now, it's just these transcripts, but we don't see any problem with having faculty members upload their PowerPoints, Google Slides, their Canvas courses. We're a Canvas school. And that leads us to the ability for the faculty member to eventually prompt against their own data, so they can come up with kind of new and innovative learning objects that we might not think of. They want to create some sort of specialized activity for their class. If they can prompt it, we have the data for it. And that's also where our instructional designers come in. They understand kind of this digital learning world in a way that the professor may not. So we kind of all work together to set this system up. So I'll turn it back over to Greg.
That's it. First, a round of applause for our presenters. And I think this is the point where we open it up to questions for any of us up here on the stage. So if you have questions, please just make your way up to the microphone. And I think these mic.
My question is for Cory. So the alt text first, is the alt text output better than what the AI alt text for Microsoft Office is for the PDFs?
So that's one of the things we're testing right now. And we'll see is kind of what I would say. What we're doing right now is, again, the alt text standards are a little squishy, if you will. And there's things that we're going to need to consider. So one of the things that could be the positive of doing a prompt-based solution is that we could take things out that we aren't comfortable with being in our collections. So there is some work around, say, demographics being exposed in alt text, and why do you even need that? So things like that. So that could be one of the positives, but we're still testing to see if it's as good or not.
And then my second question is, because alt text is just one of many things involved in PDF remediation.
Yep.
Does the AI, it does the file properties, the headings, the tables, both simple and complex, figures versus tables when people paste tables in?
Yep. So most of the Adobe API tools will do, again, the framework of the document and nails all of that. The LLMs can step in and do pretty much everything else. There is one piece it cannot do that is still human-based, and that is when you have, say, a PowerPoint, and there's some sort of color tone issues between the background and the font or the typeset. There is no current solution on the market to immediately do that. That is still a human solution or intervention to change that. Luckily, many journal articles don't have that issue. It's usually fairly standard, white background with a dark text. But that is the only part from end to end that we could not solve for. And based on what's in our collections, that wasn't a deal breaker for us.
Okay. And then just two last questions about specific kinds of PDFs. Have you run LaTeX generated PDFs through it? And have you run post prints from publishers through it?
We have not.
Two really problematic.
We've not done either of those. Okay. We are focusing on really, again, think like Word to save as PDF, sort of more digital at the moment. We will shift to more digitized content next. And then a lot of the publisher's content I sort of have on the shelf yet to, because who's responsible is another question that we could have about that. Yeah.
Okay, thanks.
Yep.
Question for Cory too. This week in my campus, Stony Brook University, and also I heard from colleagues in federal agencies who are in DC. Suddenly this week, there's a big boom. Everyone wants to talk about this and they want a quick fix immediately. Now I'm doing some kind of managing up with senior leadership. How's the case at OSU? They know it's kind of very expensive. It takes time.
So the governance sort of around this, which I think is where the question is sort of going to, is still murky, I would say, at my institution, about who's responsible for what. We have a very good central IT group, but they don't touch necessarily everything that's in a college or a unit. So that's what I was sort of saying is we weren't going to sit around and wait for that institutional plan, if you will, when we're at the scale that we're having to deal with. So we're focusing on what is in our collection in the libraries that we could then, hopefully find a solution for, and then being very open to open sourcing everything. And then I could hand that off to my central IT unit. I could hand that off to anybody in here, anybody in the world, because you're right. Everybody is starting to realize this, it seems like, and so I'm welcome to a little bit of the stress that we've been living the last few months. But again, by sharing all this content, you could hook this into your systems or build very similar types of things. That hopefully that will get us to it, because there was one state government that I know that has 500,000 PDFs that need to be done, that aren't archived, that are active living sort of things. And in library land, the definition of archive does not apply to us because our archive is living and always being touched by researchers and patrons. But yes, the temperature keeps rising on this topic. Hopefully we can solve some things on our side and have a solution that people can look at and then just give them the code and the source and then go from there.
And I'll just add on to this that the code that the KIC team developed for Ohio State University is already open source. You can go to the Arizona State University Cloud Innovation Center website and get the access to the GitHub repository there. AWS is already working with several other institutions because Cory, I think, shared this with the Big Ten Academic Alliance meeting, and that generated some conversations. We've also, to your point, been engaged with state and local government agencies because they also fall under these new DOJ requirements around accessibility as well. So there is a lot of movement on this, and what we have seen, to Cory's point, is every institution is sort of approaching it differently because it's a new regulation that has not been tested in the courts yet. And so there's a lot of interpretation involved in how individual institutions or state and local government agencies are going to comply. We have time for a couple more questions if anybody has them.
No. There's time, Tom. Stu Snibben from Harvard. I guess a question for Sarah about handwriting recognition. It's a pretty sophisticated problem you try to solve. I think in kind of traditional library world with archives, feels like handwriting recognition, just basic handwriting recognition of kind of old documents, has long felt like the holy grail for enhancing discovery. Yes. So from your experience, I was seeing numbers like 97 and 100% accuracy. Are we there, like with untrained handwriting recognition for kind of a large portion of our handwritten documents? I mean, obviously there's lots of different scripts, there's lots of different languages, there's lots of crazy permutations, but I'm just curious from your experience, like how close are we to being able to kind of throw our content at these models, these multimodal models, untrained, and get good kind of results, as opposed to some of the gymnastics that we do or are planning on doing on training against data sets and building kind of bespoke pipelines?
Thanks for the question. I'm going to be very honest. I don't think we're there, but we're getting closer. What this project in particular taught us was that it is really depending on your precise documents or what is really containing. We noticed, this has been done also in a small subset of our handwritten records, so it still needs to be seen if it's really performing that well. The other thing is, like I mentioned, the method we used to measure accuracy was probably not the best, and we learned that by trying precisely. Kind of a small fun anecdote is that, and I didn't want to show you this because we were right after lunch, but there was a record about diarrhea, and portion of it was actually describing the consistency of the stool, and the AI hallucinated completely on that part and started to describe it as a black ground coffee beans. And I thought, like, why is it talking about coffee? And then funny enough, in November, that was the first time I presented about this project at the Department of Medicine at Weill Cornell. And we got a lot of physicians approaching. They were pretty excited, but somebody, actually an older physician, told me, well, this hallucination kind of makes sense to me. Because we have a condition that, or an expression we use in medical term to describe vomit consistency that is called coffee ground emesis. And that made sense. There was like a bulb lit up in my head. I said, okay, so it's just confused, but it's not doing such a bad job. You just need, again, and that's the second point that I really learned, good curators, it's essential. And so if one thing that I would take out of this experience is that surround you with people that are subject matter expert that can really check what you're producing and tell you how good or bad it is. And that's kind of a lesson learned there. Yeah.
And I'll tag on to that too. One of the interesting, so I think we started this project in August. Is that right? Yeah. And Claude Sonnet 3.5, which was one of the models used, was released in July, right? So if we had done this 3 months earlier, it would have been significantly more difficult. That's how quickly the technology is advancing. The other thing to keep in mind, and I'm glad you brought up that example, Sarah, is there's a difference between what a multimodal language model like Claude Sonnet 3.5 can do versus traditional OCR like Amazon TextRact.
Right.
Amazon TextRact doesn't have any concept of the semantic meaning of what it is doing. It's literally looking at this and saying, is this an H? I think this is an H. Or is this an H? No, it's probably a Y. That is image recognition machine learning. Whereas what the generative AI is doing is both that and then looking at the context of the language around that to autocorrect basically the image recognition aspect. And so we can see better accuracy results with the generative AI like Weill Cornell saw, but we can also see hallucinations with the generative AI that you don't get with traditional image recognition-based OCR. And so there are trade-offs here, and to Sarah's point, having that human in the loop to help check and correct or verify those things is still super important.
Yep.
But talk to us again in 4 months, and there'll be another new model, Stuart, that is going to change everything as well.
Yes.
Okay. Well, first off, I have to say all three presentations extraordinarily polished, and you've really demonstrated a lot of capabilities of matching a business case and very thoughtful application that stay in line with ethics and the business need. It's great to see. I'm wondering if you might show a little bit of the man behind the curtain here. I think you said at the beginning that you were not. I think you were not data scientists. I don't think any of you were machine learning software engineers. And you're talking about work cycles are 4, 6, 8 weeks long. How much of that was at the total process, or did you spend a lot of time upfront framing the project, understanding the right technologies, understanding if the data was there, if this was a good match? And how much of the work, so 3 questions. One is, what was the total length? How much was really within your team or relying on people at Amazon that Greg described? And then what do you plan to do next? Is this one and done, or do you think this is a sustainable approach to your business needs?
I guess I can start. A lot of questions there. I'll start with how we plan for our, like, how to use our resources. 1 month is really, really short, but we were, like, the problem was already there, so we knew we wanted to digitize and make more those patient records more accessible, and especially in light of we're seeing in New York City at the New York Presbyterian Hospital more and more rare diseases coming back, such as tuberculosis, and a lot of physicians were asking, well, do we have any records on how we used to treat those, and how do you recognize it even? So that kind of stemmed the kind of the conversation, and we knew that we had those records that we wanted to make available. So the problem was there. Our VP, Kurt Cole, he's really into technology, obviously, and he immediately thought of this application with the AWS opportunity that he heard of. And so that's how the dots were kind of connected. In terms of our interns, I really wish we had them for longer than a month. It's short, very short. But what helped us is that Kurt Cole had a very well-defined project he had in mind, and he had those connections with the Leap of Faith as well. So it was kind of already discussed beforehand, and what it needed is just like this small push to materialize. So, and our partnership with AWS really allowed that. Our interns were also stellar, I must say. But we struggled, like setting up things in a quick manner. So we easily lost two weeks with technical issues on setting up things correctly on AWS. I mean, our AWS support was fantastic, and they really helped us actually decide about the models to use, Claude versus something else. So they were like extremely helpful also in that regard. I mean, nothing is perfect. Obviously, you have to try, but we were very happy the experience in general, and definitely not a final point. We are actually already working with Leap of Faith to have a second set of interns to develop, especially the intelligent medical object integration. Hope that answers.
So on our side, I was fortunate that ours was fairly straightforward. We knew what our problem was or what we needed to get to, because we had both accessibility standards we could work off of, but also this set of rules that we could look at and sort of define that. So when we did the sprint with the Kick team, it was really myself, and then I brought in our digitization lead, Amy, who's incredible because she has such familiarity already with both accessibility and content like PDFs or TIFFs. And then Terry Reese on my team, and some of you may have met Terry over the years. Terry is absolutely brilliant. So he's a full faculty member at Ohio State within the libraries. I brought Terry in. So when we did the handoff from the Kick team, and they provided all their documentation, and like Greg said, it's all out there on their website, Terry was able to quickly sort of pull it apart and then start thinking about what is next. But he's literally a team of one, so I'm very fortunate to have him. And then now he's going to work with my sort of infrastructure team, my cloud infrastructure team, which is only 2 people, but on how do we implement this? And we're sort of, again, taking steps. As we analyze sort of the accuracy of things, it will be a little bit bigger library team that provides input and makes sure we all have trust and comfort. But as far as the technical work, it's really 2.5 people total.
Yeah, it's we kind of have a similar experience. It's a team of 2 programmers. Amazon came in to get us from our local server to their cloud, and that was 3 days a week, or 4 days a week, 3 hours for 4 to 6 weeks, somewhere around there. But we had the code before that. The code, the system, we kicked around different ways to put it together. And I mean, I think probably, and doing other things at the same time. I mean, this is not, for either of us, this is not like our full-time thing at the university. We were, kicking it around for 6-9 months of figuring out kind of what we wanted to do. And then there was time before that of, researching things like the ethics and all that kind of stuff. So, the project's been going on for about 2 years in various form. And, having that knowledge graph, like I said, now gives you all kinds of use cases that you could build on it. So, we're constantly looking at that and seeing what we can do with that.
I think the one thing I would add from the AWS perspective, so all of the innovation programs that I talked about are designed, as you just heard from the team here, to be accelerators, right? They're the kickstart or the jump start to get you from point A to point B, to get a proof of concept done, to get a prototype in place that your team can then start to leverage and build off of. And so a lot of the innovation work that we do with academic institutions is focused around that, right? Is how do we help you get over that first hump using the years of experience and the smart people that we have at AWS to accelerate your innovation so you can get to that knowledge graph and open up a whole bunch of different use cases, or figure out what the best model for the handwriting recognition is going to be, or get through the first, 80 to 90% of the accessibility, and then you can start to refine and use pieces of that for other projects on campus. All of those innovation programs are available to you all too. They are nomination-based. The teams are relatively small, so there is a nomination and selection process that we go through with those. But if you're interested, talk to me or your AWS account manager, because beyond there, those 3 are just the tip of the iceberg. There's a bunch of other options out there as well. So we're a couple of minutes over, and thank you all for your attention and attendance.